Hello friends, welcome back to the channel. As part of our Kubernetes series, today we are going to talk about something very important in real world clusters, the Gateway API. If you have used Ingress before and felt this works but it's limiting, then this video is for you. Earlier in Kubernetes, whenever we wanted to expose our application to the outside world, we mostly relied on Ingress. Well, Ingress worked fine for basic HTTP routing, where we define a host, add a path, and point it to a service, and that's it. But as clusters became larger, shared by multiple teams, and more complex, Ingress started showing its limits. So let's quickly understand why Ingress started becoming a problem. Now let's talk about the limitations of Ingress. No proper multi-tenancy support. Ingress doesn't understand team boundaries. If multiple teams share the same cluster, one team's ingress change can accidentally affect another team's traffic. No strong namespace isolation. Even though ingress objects live in namespaces, the actual routing logic is shared at the ingress controller level. So everything feels loosely separated but tightly connected underneath. No RBAC at feature level means no role-based access control at feature level. Ingress permissions are all or nothing. If you give someone access to Ingress, they get control over everything: routes, TLS certificates, and load balancer settings. There is no way to limit access to just one part, like allowing a team to manage routes but not security settings. So it lacks fine-grained control, which can be risky at multi-team environments. No resource isolation. With Ingress, routing rules, load balancer behavior, TLS, and policies all live together. There is no clean separation between infrastructure responsibilities and application routing. Limited extensibility. Ingress works mainly for HTTP and HTTPS. If you want advanced traffic control or other protocols like TCP, gRPC, or custom routing logic, Ingress quickly hits its limits. So in short, Ingress is simple, but when system grows, this simplicity becomes a limitation. This is exactly where Gateway API comes into the picture. Gateway API brings support for TCP, UDP, and gRPC routing, not just HTTP like traditional Ingress. It also supports advanced traffic management features such as canary deployment using traffic splitting and weighted routing, SSL redirect, path rewrites, and rate limiting. One important point to focus on here: Gateway API is not a built-in Kubernetes resource by default. It is enabled using CRDS, custom resource definitions, and it requires a compatible gateway controller to actually function. So just installing Kubernetes alone is not enough. You need a Gateway API compatible controller similar to how Ingress needs an Ingress controller. So we can say Gateway API is specifically designed to solve the limitations of Ingress. Let me take you to the official Kubernetes documentation for Gateway API on kubernetes.io. So this is the official Kubernetes documentation for Gateway API on kubernetes.io. If you look at this page, you will notice that Gateway API is described as a family of API kinds that provide dynamic infrastructure provisioning and advanced traffic routing. This is very similar to how Ingress works. Ingress itself is an API that Ingress controllers understand and implement. In the similar way, Gateway API is a set of APIs that Gateway API controllers implement. So Gateway API is not just one object, it's a collection of APIs that work together to make network services available using extensible, role-oriented, protocol-aware configuration mechanism. And the goal of all this is very clear: advanced and flexible traffic routing. Gateway API solves many challenges that Ingress had. So you can think of a Gateway API as a more advanced and modern version of Ingress. With Ingress, we usually define everything in one single object, like host, multiple paths, backend services, annotations, TLS rules. Everything lives inside one big Ingress YAML. But with Gateway API, we can now build routing rules in a modern way instead of packing everything into one object. If you are familiar with Ingress, you know that Ingress is basically one rule that defines how traffic comes in and what happens to it, all in one place. Gateway API follows a similar idea but with a role-oriented design. And this brings us to designing principles of Gateway API. Gateway API resources are modeled around organizational roles involved in Kubernetes networking. There are three main roles. Infrastructure provider. These are teams or cloud providers who manage the underlying infrastructure. For example, providing load balancers or networking for multiple clusters and tenants. Next, we have cluster operator. These are the people responsible for managing Kubernetes clusters. They care about things like network access, security policies, TLS configuration, permissions, load balancing behavior. Then we have application developer. These are the developers who run the applications inside the cluster. Their focus is simple. They write a code, they are concerned about which domain, which path, which service should receive the traffic, means their application should run in the cluster. And here is the key idea. In a large enterprise, those roles are clearly separated. Infrastructure teams don't want to worry about application paths. Application developers shouldn't worry about TLS certificates or networking ports. Cluster operators shouldn't have to deal with cloud provider internals. So Gateway API allows us to model traffic exactly around these roles. So each team manages only what they are responsible for. Portable. Gateway API specifications are defined as custom resources and are supported by many implementations. What this means in simple terms, you are not logged into a single vendor. You can move Gateway API configurations between different controllers or environments without rewriting everything. So if today you are using one gateway controller and tomorrow you switch to another, your Gateway API manifest can still work. This is what we mean by portability. Gateway API is also very expressive. It supports advanced routing features like header-based matching, traffic weighting, canary deployments, and others. With Ingress, many of these features were only possible using custom annotations, which were controller-specific and hard to maintain. Gateway API is highly extensible. It allows custom resources to be attached to different layers of the API, enabling fine-grained customizations. For example, application developers define how traffic reaches their service. Cluster operators define TLS, security, and networking policies. Infrastructure providers handle cloud-level routing and load balancing. Each role focuses only on its responsibility without stepping into someone else's area. That separation of concerns is one of the biggest strengths of Gateway API. Well, both Ingress and the Gateway API serve the same high-level purpose. They allow services inside the Kubernetes cluster to be accessed by clients outside the cluster. So the problem they solve is the same. But Gateway API is trying to solve this problem by fixing the drawbacks of Ingress. Now big question is, how does Gateway API do this? The first major design decision the Kubernetes community made was, instead of providing Gateway API as a single resource, they broke it down into multiple resources, each with a clear responsibility. So if we talk about Gateway API resource model, it has three main resources. The first one is GatewayClass, the second one is Gateway, and third one is route, HTTPRoute or gRPC route. Let me take you back to the Gateway API documentation to explain this clearly. Here under resource model, we can see Gateway API has four stable kinds. The first one is Gateway class resource. A Gateway class defines a set of gateways with a common configuration and it is managed by specific controller. If you think about the Ingress world, this will feel familiar. For example, you might have an Nginx Ingress controller or an HAProxy Ingress controller, and you use an Ingress class to decide which controller handles which Ingress resources. The same way, Gateway API follows the same concept but in a cleaner and a more explicit way. With Gateway API, a Gateway class specifies which gateway controller will handle traffic, and the controller could be Nginx, HAProxy, Envoy, and so on. This is the highest level API in Gateway API. Here, important points to remember: Gateway class is cluster scoped. it is not live inside the namespace. Gateway API resources are CRDS, means custom resource definitions, unlike Ingress, which is built-in resource. Typically, gateway class is defined by cluster admins or infrastructure teams. Next comes the gateway resource. Gateway and HTTP resources are namespace scoped resources, and they can be created by DevOps engineers, platform teams, or application administrators. The gateway resource defines which gateway class to use, either Nginx, Envoy, HA proxy, etc. Also how traffic enters the cluster and listener configuration like ports and protocols. It can also integrate with cloud load balancers. For example, in AWS, how should the AWS load balancer behave? In Azure, how do we want to manage the Azure load balancer? So gateway is the actual entry point into the cluster. Now comes the routing layer, HTTPRoute. This is where most application level logic lives. HTTPRoute defines which backend service should receive traffic, on which path, on which port. And this is where Gateway API really shines. Everything we usually struggled within Ingress, such as web application firewall support, HTTP redirects, traffic limiting, canary deployments, traffic splitting and weighted routing, all of this is natively supported in HTTPRoute without complex annotations. We also have route like gRPC route, TCP route, UDP route. So Gateway API is not limited to HTTP anymore. So to summarize this model clearly, gateway class defines by cluster admins or infrastructure operators, implemented by controllers like Nginx, Envoy, Istio, etc. Then gateway defined by DevOps or platform teams, chooses which gateway class to use and how traffic enters the cluster. Then HTTPRoute, this is defined by DevOps or application teams, handles routing rules, traffic splitting, redirects, security features, etc. This gives us very clear separation of responsibilities using Gateway API. Now let me show you a very practical example that clearly highlights why Gateway API is better than Ingress. Let's say in Ingress we want to split 20% of the traffic to a new version of our service. A typical canary deployment scenario. How do we do this with Ingress? In the Ingress world, especially with Nginx Ingress, we need to use controller specific annotations. For example, we have to write something like this. Let me explain what's happening here. Here, Nginx Ingress Kubernetes.io canary true. This tells the Nginx Ingress controller that this Ingress is a canary Ingress, not a regular one. Then Nginx Ingress Kubernetes.io canary weight 20. This tells the controller to send 20% of the traffic to this service. This works, but there are problems. These annotations are Nginx specific. They are not portable. You need to remember exact annotation keys. Your YAML becomes harder to read and maintain. With Gateway API, if you are using HTTPRoute resource, this becomes much simpler and cleaner. Let me show you that. So here is the sample traffic split using HTTPRoute. Let's understand this. We are defining backend reference. Each backend has weight. Traffic is distributed based on weight values. Weight 10 means 10% traffic. Weight 90 means 90% traffic. So if you want 20% traffic, you simply change this to 20. That's it. No annotations, no controller specific configuration, clear, readable, portable YAML. This is exactly why Gateway API is considered more expressive and easier to manage than Ingress. So if we talk about key difference between Ingress and Gateway API, Ingress uses annotations for advanced features. Gateway API uses native fields. Ingress configs become complex and controller dependent. Gateway API configs are clean, modular and portable. Now that the Gateway API concept is clear, in the next lecture we will move into practicals. I will show you a live demo of installing Gateway API, creating gateway class, configuring gateway and HTTPRoute, and routing real traffic in real time. So stay tuned. If you found this helpful, don't forget to hit like, share and subscribe. See you in the next video. Happy learning!